I'd like to introduce your next keynote speaker. It is Hao Zhong, CEO of ScaleFlux, and Hao, before joining and founding ScaleFlux, he held senior engineering positions at Fusion.io, Sandforce, and LSI. And just from that alone, you can see that he's eminently qualified in order to lead ScaleFlux in this new computational storage arena. Hao has a PhD in electrical engineering from Rensselaer Polytechnic University, and he's recognized as a pioneer in the development of LDPC technology. So please welcome please join me in welcoming Hao Zhong, CEO of ScaleFlux.
Thank you, Frank. Good afternoon, Fresh Memory Summit. It's exciting. As the only startup that receives the award together with so many distinguished public companies, we are really honored. The credit goes to our team. They did a fantastic job. And also, thanks for everyone voting for us. With that, let's kick off with a short introduction video.
The world today runs on data-driven applications. Data center storage is under pressure to support massive data growth and process it in real time. The transition to flash storage has opened accessibility to this data. But there's a problem. Scaling application responsiveness with exploding storage demands is costly, and the main obstacle has shifted to computational processing limitations. There has to be a way to break through storage and processing bottlenecks at the same time. Introducing ScaleFlux, the pioneer in computational storage. By taking an SSD with terabytes of low-latency flash storage and adding complex compute engines that are directly integrated into programmable hardware, ScaleFlux opens processing and storage I/O bottlenecks by bringing compute right to the data. Computational storage easily integrates into standard servers. It provides responsive performance, affordable scaling, and an agile platform for compute and storage-intensive applications. Unleash data-driven apps with ScaleFlux Computational Storage.
Computational storage. Resonating? Glad to be here to share with you how far computational storage has come. In fact, at last year's Fresh Memory Summit, the industry did not even agree on a name for the technology. There are names like intelligent SSDs, in-situ processing. For the first time, ScaleFlux introduced computational storage in only one short year after getting into the market and working with many of you in the industry. We are so grateful to receive the award and being recognized for this newly defined category of computational storage. Some of you may be wondering, what's the big deal? What exactly is computational storage, and how does it work? I'll start with one use case, so you can get some sense out of it. Then I'll talk more about computational storage. One use case is from AliCloud, one of the largest cloud service providers, who sees immediate and dramatic benefit from computational storage in their infrastructure. AliCloud, technical issue. Okay. AliCloud identified 70% of their growing enterprise customers facing three major infrastructure-related issues. 1 second. It's turning. Great, it's back. So they're facing three major infrastructure-related issues. The first one is high cost. The cost is in terms of licensing fee, migrating application to new infrastructure, and also maintaining system on-prem. Okay. The second issue is the data islanding. There's so much transactional data going on, and the data often gets duplicated from transactional database to analytic database. So the data cannot be shared between applications. This also leads to the third problem, which is data explosion. So this makes IT infrastructure scaling extremely cost prohibitive. These are big problems, right? But the big problems also means great opportunities. So for the solution, any solution Ali Cloud demands should be at cloud economics, which means the customer can pay for the service, and meanwhile, what's even more critical is keep infrastructure cost low, which means, in other words, they want to do much more with less. The second is unified storage. By building hybrid platform that enable the same exact data can be shared between applications. In this way, we do not have to move the data across applications, which also reduce the data explosion problem. The third thing is, for highly efficient system, we need the computing power focused on the data analytics, not wasting on massive compute on the data movement. So this is where the ScaleFlux computational storage comes in as a critical component in the infrastructure. Also support an amazing solution called PolarDB. PolarDB is a hybrid transactional and analytical database that can do real-time processing on top of transactional database. So there's no more lagging between two types of workload. And also because of unified storage, the cost is much lower. There are a lot of other cool features in PolarDB. The one key enabler for this technology is hardware accelerated computation at a storage device, which is called computational storage. What's the magic? First, intelligently manage the data so we can optimize for the performance and the latency. Second, by bringing the compute to the data so we can do pre-processing for the data and save massive amount of data movement. In this way, we can also save tremendous power, storage cost, and processing latency. The third thing is programmable hardware, because we need the solution can evolve in the system. In this way, we can deliver from idea to the proof of concept in only 6 months. And the result is extremely promising. Together, we are seeing 10 times improvement in terms of analytic and transactional processing capability. And also, with the unified storage, we only need half of the storage capacity. 10 times at half the storage cost. Computational storage is really transforming how the IT infrastructure is architected and how the flash storage is deployed at a large scale. Now it's getting more interesting, right? Let's dive in and talk about how the computational storage should be designed in the right way. We are big believers for cohesive design of flash storage from 3 major aspects. First one is open channel flash management for controllable data placement. The second is computation acceleration for solving both computing and storage bottlenecks at the same time. The third one is solution agility for easy application integration. Let's first look at why we choose open channel flash management. In today's cloud environment, especially for hyperscalers, people like open channel management for reasons, because it can help optimize the flash utilization, and also it improves the performance and the latency. Let's see what's the design points. The first one is to enable the application to control the data placement. With the application awareness, we can place the data on the drive for the performance and latency. And the second design point is design the FTL, or flash management, in a global view. It provides more dimension to minimize the over-operation redundancy, as well as the write amplifications. And the third point is the capability to supply multiple tenants. Why this is very important? Because there are so many users in the cloud, and we want them to be able to use the flash storage without interfering each other with a guaranteed performance, latency, and consistency. Another popular application in the cloud is the KV store. As we know, the KV store, they want to access data in an object-oriented way. So by simply mapping the KV store on top of block I/O storage is leaving a lot of performance on the table. And what we can do with open channel flash management is we can tailor the FTL, optimize it for KV store. In this way, we can have really high efficient KV interface and convenient for applications. Let's look at the benchmark result. This is a benchmark of Aerospec certification. Aerospec is the best performing NoSQL database based on flash storage. It elegantly uses the flash storage for the performance and scalability. And it even beats the Redis, which is in-memory key value store database. The reason is from software, they optimize the way so to utilize the consistent and low latency of the flash design. Here, what we are measuring here along y-axis is the read transaction percentage that over 1 millisecond. As we know, it's important to minimize that long latency, right? So the number, the lower, the better. During the test, the first NVMe SSD actually stops as the garbage collection kicks in. And the second NVMe drive can continue run, but at much higher latency and percentage of the latency over 1 millisecond. Let's look at the host FTL optimized computational storage. We can see much better latency and consistency. Right? So this is a critical base when designing computational storage. Of course, there are many other values for computational storage. For example, it's easy tune for the application, and also it enables easy transition from 3D NAND generations, particularly with the QLC getting into the production. And also, it can easily extend it for other storage class memory, like CrossPoint and MRAM. There's no doubt a lot of value in this model, right? To make it mainstream, there are a lot of initiatives will be needed, like Microsoft Denali project, like Ali Open Channel SSD project. We'll be happy to help to drive the standardization in this area. Let's switch our gear a bit and talk about why does it make sense to have the computing engines into flash storage. As a tech geek, the next slide is going to be my favorite one. So ready for acceleration? Let's go. In a server, usually data move from the storage to the memory, and the CPU does the computation. Right? As the data grow, you will need more storage, more memory, and more processing power. What do? Most people will just simply add in more servers, scale it out. However, the problem is the data is growing much faster than ever. So the CPU will need to process a lot more data to manage those data in the background, as well as supporting more and more applications. Meanwhile, there are more data are loaded from storage to the memory. This is not sustainable. So we must solve both computing and storage bottleneck at the same time, solve them simultaneously. How to do that? The best way to do that is actually bring the fast storage, which is flash, and also the heavy lifting computing function. Bring them together to form the computational storage subsystems. In this way, we can reduce massive amount of data movement. So we do not have to throw everything to the CPU and the DRAM. The second is we can speed up the data-intensive fixed functions, as we can run much more efficient than the x86 CPU for this type of function and workload. And the third benefit is actually very important is the parallelism. By parallelizing compute across multiple drives, you are going to see even more gain. As you can add more and more drive. Actually, you actually can add dozens of drives in a server. Right? This is the key principle behind the computational storage. Of course, there are many trade-offs and considerations in the last few years that we have learned. We have to make it practical for the customers, not just for a science project, right? So people tried many different ways. For example, using ARM processor to do some local processing and offload some type of work. However, in the data center, if the x86 is not good at those functions or workload, the ARM CPU is not going to do any better. So in this case, the FPGA is a great choice. Manish from Xilinx, early on in his keynote, he demonstrated a tremendous number of applications that FPGA can help. And we are big believers on that as well. So that's why we are focusing on the data-intensive and the fixed functions that we can implement in the FPGA in an efficient way, and also run much faster than the x86 CPU. By parallelizing the computation across multiple drives, we are going to see even more gain. Let's look at a few examples. The first example that I'm going to show here is how the computing on the compression scales over multiple SSDs versus computational storage. Let's plug in 4 SSDs in a server and run the compression for the write file with the compression. And then we can see the performance actually cannot scale because this is a CPU-bounded problem. The computational storage changes the game. As we add more computational storage device into the system, we can see the performance can actually scale together because when you add more storage I/O and the capacity, you also balance the computation capability. The second example I want to show here is a fuzzy search. As you know, the x86 CPU is very good at exact matching, but for the fuzzy search, it's really slow on the x86 CPU. In this case, we can plug in 24 drives in a storage server and run the fuzzy search. As you can see, with a regular NVMe SD, we are not going to see the performance scaling. What's the reason? Again, it's a CPU-bounded problem. Each of our x86 CPU can run about below 50 megabytes per second for this type of fuzzy search. And with 16 cores, what you can get? It's only around 700 megabytes. With computational storage, each of the device can run about 3 gigabytes per second. And with 24 drives, you are going to see around 100 times improvement. That's the power of computational storage. Of course, identifying the right workload and the function is extremely important. We started accelerating the common algorithm at the infrastructure level. The reason we started here is we want to quickly identify the wide market fit for the computational storage. As we move to the platform level, especially for the big data and the database platform, there are a lot of opportunities. We find that a lot of algorithms are actually ideal to execute at the storage engine level just like the one that we worked with Alibaba. The computational storage is an evolution. As we see, there are more applications like AI, genomics, CDN, and search. They all demand more fresh storage. So we are seeing more opportunity to accelerate those applications as well. The last point I want to talk about is the solution agility. In today's market, the agility is extremely important. Customers often ask six months window to demonstrate the value, right? And also the non-vendors, they are speeding up the development from the TLC to QLC, and sometimes even shortening the cycle from 18 months to 12 months. Also, oftentimes, customer will ask, okay, I want the option to update the hardware features. With all this dynamic, the agility is the critical thing for us for the success. So the way to achieve that is to have the agility along the entire software and hardware stack. From a hardware point of view, it's important to have programmability, so we can adapt a new fresh media and also add new acceleration functions. From the fresh management layer, it's important to have controllable data placement for optimal performance and latency. At the application level, it's very important to keep it simple, keep the simple interface so we can easily integrate with many applications. This model really enables the full stack optimization from the application interface all the way down to the storage hardware. To make things easy, we actually integrate multiple acceleration features with a variety of applications in a 10-key fashion, so everyone can plug and play easily. A lot of customers, they see tremendous performance boost in applications from SQL, NoSQL database, to big data platform like Spark and Hadoop. And to make things even easier, we actually qualified the computational storage with Tier 1 OEMs. They are EMC. They provide the ESI qualification program targeting for the large-scale deployment. Inspur, they enable the multiple big turnkey solution for big data applications. And another exciting thing is Packet, a bare metal, high-performance cloud service provider. They just announced the first computational storage in the cloud, so you can easily use that in just a few minutes. At the end of the day, what we would like to see, of course, happy customers. Just for a few examples, Playtika, the leading online gaming company, hosting many popular games like World Series Poker, right? Ever heard of that? They are using computational storage for super fast NoSQL deployment. And Cox Media, they're working on the online ad tech. They can easily integrate computational storage in their infrastructure and enjoy the cost-effective in the applications. PhonePe, the online payment service for Flipkart, dealing with one of the largest e-commerce in India. They are scaling multiple data-driven applications with ScaleFlux. So fast, easy, agile, getting so much out from the fresh storage deployment. That is what computational storage is all about. It's exciting to see that the market is demanding computational storage, and we view it as a new wave of fresh innovation. You may still remember, just over 10 years ago, the whole industry, the innovation is focused on SSD and its controllers. A number of startups actually did a great job on early productization on SSDs. Actually, I saw many our Salesforce buddies and Fusion IO buddies. Hey, guys. And the dramatic improvement, the dramatic move and huge improvement at the storage component level actually stimulate another wave, new wave of innovation at the system level, particularly for all-flash arrays and hyper-converged systems. Companies like Nutanix, Pure Storage, they did a fantastic job on that. What we are seeing now is actually the third wave of flash storage innovation. The time of computational storage is here, and you do not want to miss the wave. With that, I want to thank you for listening into how the computational storage is impacting the industry. Our journey has started, and we'd love to hear your feedback and see how we can help. We are ScaleFlux, the pioneer of computational storage. Thank you. Oh, by the way, if you get a chance, please stop by our booth 113. A lot of cool stuff. See you there.